Hello, here is Zoe. Let's talk about our homework 2 question 6. Okay. Uh, uh, well, that's fine. Okay. So remember we have 10 instructions and two systems. One is the 32-bit and another is 64-bit. That is 4 bytes and 8 bytes. And each type of the data type, they have the different size, right? For the double, the size is 8 byte, and the different thing is for the floating, the pointer. The pointer for 32-bit system is take 4 byte, but for the 64-bit takes 8 byte. So that will be slightly different for our questions. And okay, let's go through about this. So firstly, remember we need to satisfy the alignment, right? The byte alignment. So the byte alignment means you should the block size should at least the the largest instruction uh, data type size. That is, you can see here we have a doubled data value. Okay, value. value. So the blocks should at least 8 byte. That is the size for both these two systems. Even though the 32 bits just have 4 byte. So that means if you are using a 32, the 4 bytes will be here, and then you should add another 4 byte to make it a 8 byte. Okay, so let's go. But firstly, you should match the 4 byte. Okay. Okay. So let's go. For the 32-bit here, we will have a char, right? One, and then another one, that is the bool, and then we go int. But for integer, we need a 4 byte. But there is, if you, but our system originally just had 4 byte. So you cannot add an integer like using 2/2 of the 4 byte. You have to meet the alignment. That is, here you should plus 2 byte here, and then plus the integer here. Yeah. So here we will plus 2, right? And then here we will get a totally 8 byte for our system. Okay, that's great. And then we get a double. Double is taking 8 byte, and then we got short. Short is taking 2, and that's the same here. As our system originally have 4 byte, we have to plus 2 more to satisfy the alignment. And what's new? The following is the float. Float is also taking 4 byte. Another is the double. Okay, is 8, and then is the char pointer, take 4, and the floating pointer also take 4. Okay, that's great. And then we have the integer taking 4. So here is also 8, right? But here just 4, and that is not enough. We have to make it more, right? Plus 4 to satisfy a 8 byte system. Well, my drawing is not that good, but yeah, that's all. So how many we added? We add 2, add 2, add 4. And how much is the originally? The originally will be, let's calculate it. Right, 14, 20, 40, right? 40. So we will have totally 40 plus 2 plus 2 plus 4. That is 48. That is the original instruction or value alignment, right? Satisfied. But how about minimize? That is, we are trying to make those plus disappear or rearrange our sequence. So how about we put these two into here, so we can make a 4 byte, right? And we put this 4 into here, so we won't need this kind of things. So with how many we save, we will save this 8 we will not need, so the minimum is the 40. That is the original, right? We will not need to add alignment blocks or bytes. Okay, let's talk about the 64-bit system here. So still we have char1 and bool, and what's new? Okay, we will have an integer with 4, and here need to plus 2 to satisfy the alignment. The alignment is 8 for our 8-byte system. Yeah, the alignment is here. And then we have the double is 8, and short is 2. Okay, plus 2 satisfy alignment, and then 4 for floating, and then double for 8, double character pointer for 8, floating point for 8, and integer here is 4, and also plus 4 to satisfy a 8-byte system. So how many we plus? We plus 2 plus 2 plus 4. And how is the original? The original should be 48, right? 48. So totally is 48 plus 2 plus 2 plus 4. Okay, it's 56. And after minimize or rearrange, we can put yeah, just doing the same thing. The 2 we go here, and then we will not need this, and then 4 we go there, so there's no need the plus, right? So the minimum is 48. That is the analysis for question 6. Thank you.